Hi guys, here's another video about the CSS Pure Mathematics Exam from 2023. This is section B, and we are going to solve question 4, item B. So it asks us to show that x is less than sine inverse x, which is less than x over the square root of 1 minus x squared for all x greater than 0 and smaller than 1. So as we will see, in order to solve this problem, we can use the mean value theorem, which we are going to recall in a bit. So let us begin. First, we start by defining two auxiliary functions f and g, both defined in the closed interval minus 1, 1, and they are defined as f is defined as sine inverse of t minus t, and g of t is t over the square root of 1 minus t squared minus sine inverse of t. Okay, and these mappings are both continuous, and they are differentiable on the open, they're continuous on the domain, the closed interval from minus 1 to 1, and they are differentiable in the open interval minus 1, 1 with this. So we know the derivative of sine inverse t is 1 over square root of 1 minus t squared. So, and we get this minus 1 here because the derivative of minus t is minus 1. And for the second derivative, again, for this part here, we use what we had before, that the derivative of sine inverse t is 1 over the square root of x squared of 1 minus t squared. And for the first part here, we observe that this mapping t over the square root of 1 minus t squared can be seen as a product of t times 1 over the square root of 1 minus t squared. So then we use the product rule. So first we derive t and multiply it by 1 over the square root of 1 minus t squared. And then we take t and multiply by the derivative of 1 over the square root of 1 minus t squared. And then we get this expression here. So as we can see, this cancels out with this. And then we obtain that derivative of g is t squared over the square root of 1 minus t squared to the power 3/2. Okay, perfect. Now let us recall, as I mentioned before, the mean value theorem. So the mean value theorem tells us that we have a function age defined on a closed interval AB, which is continuous on this interval and differentiable on the interior, so on the open interval AB. Then there exists some constant c in the interval AB, such that the derivative of h at c equals h of b minus h of a divided by b minus a. So now we are going to apply this result to our functions f and g. So now we fix x, some x greater than 0 and smaller than 1, and we observe that since the functions f and g, they are continuous on the closed interval minus 1, 1, and differentiable on the open interval minus 1, 1. In particular, they are continuous on the interval 0, x, because x is greater than 0 and smaller than 1, and differentiable on this interval 0, x open. So we can apply the mean value theorem to these mappings restricted to this interval 0, x. And this tells us that the mean value theorem tells us that there exist cx and dx in the open interval 0, x, such that the derivative of f at the point cx equals f of x minus f of 0 over x minus 0, and the derivative of g at the point dx equals g of x minus g of 0 over x minus 0. Okay, now we recall that the definition of f and g, just recalling it, f is defined this way. So if we plug 0 here, f of 0, the sine inverse of 0 is 0. When I plug 0 in t, I get 0, so f of 0 is 0. And if I plug 0 in here, I get 0 because 0 over 1 is 0. And again, the sine inverse of 0 is 0. So f of 0 and g of 0 are both 0. So when I apply here, both this guy disappears and this other guy also disappears. And x minus 0 is x and x minus 0 is x, okay? So I get this. I get sine of x minus x, which is the expression for f at x, over x, and on this side I get x over the square root of 1 minus x squared minus sine inverse x divided by x. And on this side, since we get the derivatives which we calculated, apply that c of x, and here applied to d of x. So I get these equalities. And now we are going to observe an interesting fact. Observe here that c of x and d of x are on the interval 0x, and x is smaller than 1. So cx and dx are both smaller than 1, greater than 0 and smaller than 1. So this tells us that this number is positive and this number is also positive. It's not hard to see. So since they're positives, we obtain that since this is the same as this, they're equal, this must be positive. And in the same way, since this expression is the same as this one, we get that this one is positive. Now again, since x is a positive number, we can multiply both these inequalities by x, and we obtain on one hand this one, and on the other hand this one. So we are done, because all I have to do is rearrange the expressions, and we get that x is smaller than sine inverse of x, which is smaller than x over the square root of 1 minus x squared. And the problem's done. It's not a hard problem. You must actually recall something about calculus, the derivative of sine inverse, and the mean value theorem, but it's not a hard problem. There's a bit of calculation, but it's fine. So I hope you enjoyed this video. Please give me a thumbs up, subscribe to the channel, and leave me a comment. I would love to hear what you think about my videos and what you want to see in my channel. Thank you very much, and bye.